Okay, welcome to a really cool lesson on mixed and entire radicals. Now, before I really get into mixed and entire radicals, there's a lot of background information you got to know. Case in point, let me show you. Okay, right here. When you're dealing with radicals, people have to remember that when you're dealing with a radical, you're dealing with this whole thing that's a radical. That whole thing is a radical. What do you mean? Well, how about something like square root, sir? Square root of 2. Guess what? That whole thing is called a radical. Well, how about the cubed root of 75? Guess what? That's still considered to be a radical. Well, what about the sixth root of 2000? Well, guess what? That's still considered to be a radical. So what makes a radical a radical? Real simple. It's got to have something called an index here. What's an index? An index means what kind of radical is it? Is it a square root radical? Is it a cubed root radical? Is it a sixth root radical? And I know what you're saying. You're like, well, there is no number here. Yeah, you know what? But it is a square root. So you assume it to be 2. Ah, but we don't write the 2 because that's just kind of makes it ugly. So just square root of 2, you know it's an index of 2. Interesting. You know the radical sign. It's there. You've seen it in every single one of these guys so far. There's the radical sign. But did you know that inside the radical sign, this is actually called the radicand? Neat, eh? That's the radicand. So the radicand for this guy would be 2. For this guy would be 75. For this guy would be 2000. Oh, well, piece of cake, right? Right. Now, I know what you're saying, but sir, are we ever going to get a question on something like this? Absolutely, you will. This is a teacher favorite. I'm going to tell you right now, it's a huge teacher favorite. The big favorite is they're going to give you a written question saying, write for me a radical that has an index of 4 and a radicand of 60. Oh, okay. Index of 4 and a radicand of 60. There you go. See how important it is to know these particular words. Very, very important. Okay, now, before we even go on to mixed and entire radicals yet, we still have some background to do. Background is this, prime factorization. What is prime factorization about? I don't know if you remember from like grade 4, grade 5, you use something called a factor tree. Break it down into prime numbers. So prime factorization right here, right out of the textbook, is the process of writing any kind of number as a product of its prime factors. Remember what prime means. Prime means divisible by only 1 and itself. Okay, so let's go and do this. How do we do it? Simple. Watch. I've got a couple numbers here. I've got big numbers, like 125. I want to break down 125. Break it down. Now, I know to look for tricks. For example, one of the tricks is the fact that this is 5. So I know that this is divisible by 5. So one of my factors is going to be 5 times. Now, if you do 125 in your head, hey, all the power to you. But if you can't, you can always bring up your calculator and just go 125 divided by 5. Boom. Oh my goodness, it's 25. Hey, look at that. Okay, so it's 5 times 25. Now, keep going. You know and I know that 25 is a perfect square. That is 5 times 5. And guess what? There's your list of prime factors. Ta-da! Now, you've got to be a little patient because you know what? Eventually, you're going to see where this goes. All right, here we go. So do you realize that we can actually write this as 5 cubed? Oh, that's kind of interesting. All right, let's go to the next one. Let's go to 196. And here's where a lot of people drive me crazy. Oh, it's horrible. I see people go out and saying, well, that's an even number. We can divide this by 2. Yeah, well, let me show you something. Interesting. Clear. 196 divided by 2. Check this out. You're going to get 98, which again is an even number. See what I mean? So why just go with 2? If you divide by 2 and end up with an even number, do you realize that you could have initially divided by 4 then? Watch this. If you take 196 and divide it by 4, check out what you have. You got 4 and 49. A lot nicer numbers. And I'm going to show you why that's important in a second here. This is 4 and 49. Check this out. 4, haha, is a perfect square. 2 times 2. 49 is also a perfect square. 7 times 7. Ta-da! There's your prime factorization right there. Now, the cool thing about this, the reason why I like using the idea of 4 here, there, sports fans, is because it avoids what's going to happen here. Okay? I've had students, I've given students this on tests, and I put down 4096, and they go, oh, well, it's even. Let's divide this by 2. So watch what happens. Check this out. They go over here and they go 4096 divided by 2, and they get this number. So, okay, they'll go and they'll write down 20 or 2 and 2048. Okay? Well, that's an even number, so I'm going to just carry this 2 along with me. I know that's divisible by 2. Let's see what happens. Okay, so here we go. Divide this by 2. Oh, look at it. I got 1,024, so I better write that one down, 1,024. Guess what? This is also divisible by 2. And eventually what happens is people keep on going and dividing by 2 and dividing by 2 and dividing by 2, and there's 2 and there's 2. I've actually had a student who did that exact question like this, 4096 on the top of the page, kept going by 2s all the way down like this, and then guess what happened? They asked me for a scrap piece of paper, which they proceeded to staple here, which had the other 2s going all the way down like this. Oh my goodness, what a horrendous waste of time. Let me show you how to do this super quick, super accurate, and it'll get rid of a lot of the mess. Okay, so go to your calculator. Let's start with the 4096 again. Watch this, 4096. Now, you know and I know it's even, we can divide it by 2. Okay, but did you realize that we can take the 4096 because it's an even number, we could have actually just divided it by 4. Oh, look at that, it's an even number again, which, remember, you're now going by multiplication. Multiply this by 2, so multiply this by 2. Do you realize that 4096 could actually be divisible by 8? Yep, there it is. Which means, guess what? You could have actually, since this is an even number again, you could have actually divided this by, yep, 16. So check this out. And this is just playing in your calculator here, folks. That's all it is playing in your calculator. So let me clear this up. Let's start it again. I could have divided this guy right off the bat, 4096. I could have divided it by 16. Oh my goodness, look at that. Still an even number. So guess what? I could have divided 4096 by, you got it, 32. Still an even number. So guess what? I could have divided 4096 by, you got it, 64. And watch this. This is the coolest part. Boop. It gives you 64 back. Oh my goodness, 4096 is actually a perfect square. So that's where we're going to end. 4096 is actually 64 times 64. And if you know anything about your perfect squares, 64 is 8 times 8 and 8 times 8. Check that out. Now, I love calling my 8s my Star Wars numbers. Why? Because, get this, watch. 8 is actually 2 times 2 times 2. And so you get 2, 2, 2, Star Wars. Check this out. 2, 2, 2. And again, check it out. 2, 2, 2. And another one. 2, 2, 2. Oh my goodness. And check out how many 2s you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is actually 2 to the 12. Isn't that wild? Yes. And the whole idea is, do you see the pattern? I absolutely do. Now, I also want to show you something else that's neat. Since this is cubed, that makes 125 a perfect cube, which means you can cube root 125 and you will get 5. Well, how about this one? That's 2 and 7. That's mixed up. No, that's okay. Look, a 2 and a 7 go together, and another 2 and the other 7 go together. Guess what? This is a perfect square. 196 is actually 14 times 14. So if you square root 196, you'll actually get 14. Oh, way too cool. Wait, we haven't even started yet. Check this one out. If we square root 4096, look what we get. We're going to get 64. But look, 1, 2, 3, 4. If you fourth root 4096, you're going to get 8. Oh, well, how about this one? If you 12th root 4096, you're going to actually get 2. See the patterns? That is so cool, and you would not see those patterns if it wasn't for the prime factorization. Now, stay tuned because I got lots more, and I'm going to show you how to use those prime factors in a second.